So, a lot of our audience, and to be honest, most people who are chemists aren't very familiar with the difference between targeted and untargeted workflows. Could you define those a little bit more?
Yeah. So conventionally speaking, in mass spectrometry terms, targeted would mean that you know the species that you're looking for, and then you can configure an analytical system to look for them. That would be a targeted way of doing things. And an untargeted way of doing things would be to use a technology that doesn't make any assumptions, that doesn't require any prerequisite knowledge. And so in our world, conventionally, that's fallen into unit mass resolving systems like triple quads or high resolution systems like TOFs or Orbitraps, for example. And so usually those approaches are associated with those different technologies. Again, there's a weird and wonderful things. You could do scanning experiments on triple quads. So nothing is hard and fast rule here, but that's typically the way. And a targeted way of doing things does bring a lot of advantages because when you know what you want to measure, you know where to look for things. You can optimize the detection of those things because you know where they're coming. And in theory, you should know something about the interferences in the environments there. You should have validated your method. And importantly, you can do calibration curves to absolutely quantify those things rather than just look at peak areas. That's one of the weaknesses associated with the untargeted approach is that usually you're just comparing peaks that are twice as high or the areas twice as great as the other peak. But in targeted analyses, you can really nail them down. Now, we're trying to bend those rules. We're trying to fill in the gray space between because there's no reason you can't deploy high resolution mass spectrometry to do exactly the same thing and see more, as long as you also have those calibration curves. There's no reason at all. There may be some technical considerations, sensitivity, speed, things like that. But we've worked to fill the gap, to really close the gap in performance between high resolution mass spectrometry and things like triple quads. So that's where we're really trying to blur the boundaries for the betterment of our users and researchers in the field.
That sounds super awesome, especially because for untargeted, you have to do a lot of like data analysis